Okay, students, we're on the last section for chapter 4, 4.7, graph linear functions. Okay, so you have seen, we're going to read this because this is always the most important, the vocab. If you don't understand the vocab, then you don't understand what I'm saying. So make sure that you take notes and you look at this. You have seen linear functions written in the form y equals mx plus b. We've been doing them, or we did y equals ax, where we did direct variation. By naming a function f, you write it using function notation. So this is the two things that you're going to have to interchange and understand. So instead of writing y, you can write f of x. That is the same as y. One of them is just written as y, and then f of x is understood to be function notation. So they're interchangeable, and you have to understand they mean the same thing. Okay, the symbol f of x is another name for y. So this is really important that you remember that and you understand that. And is read as the value of f at x, or simply as f of x. It does not mean f times x, so we're not multiplying f times x. You can use letters other than f, such as g or h, to name functions. So f is just put here to refer to this function as an f. But we could have a g, we could have a d, we could have a b, it doesn't matter. Sometimes when you have two functions, you call one g, one h. So that's just a way that you understand what the function's called, and if you have more than one, that you can differentiate between the two of them. Okay, so we're going to go on now, and we're going to find the value of a function. So let me write it down. It says, find the value of the function of f of x equals 3x minus 15 when x equals negative 3. Okay, so let me squeeze that in. Sometimes that's a little bit. Okay, so actually I should write this because it's kind of a little bit cramped. I'm going to say right here so we can see it, when x equals negative 3. All right, there we go. Now we can fit it onto the screen. Okay, so remember, f of x is the same as saying y. All right, they're just two different forms of the same thing. This is referred to as functional notation, or if you see it as y, you could interchange y with f of x. They mean the same thing, so you have to understand that. So they're just saying find y, or f of x, when you plug in an x of negative 3. So what is the value? So all you're going to do here is you're going to, sometimes what you'll see is where this x is, they plug in a negative 3 to show that's what they're putting into the function. So sometimes in a test, if you see that and it doesn't say anything else, it means take the negative 3, which is the value of x, and plug it in where you see the x. So we're just going to evaluate 3 times negative 3 minus 15. 3 times negative 3 is negative 9. Negative 9 minus 15. You should know that the value then of this is equal to negative 24. So that's all they want you to do, is just plug in. So let's go ahead and try another one. So here the function again is an f of x. No, this time it's an h of x. Okay, same thing, still means y, equals negative 7x. And they want you to evaluate when x is 7. Okay, so all you're going to do is you're going to plug in. Okay, so negative 7 times 7, so it's real easy, and the answer should be negative 49. So negative 7 times a positive 7 is going to give us a negative 49. All right, so you have to read the instructions real carefully, because when they ask you to evaluate an x, they're just giving it to you, plugging it in. When you solve it, you're really just finding y. Okay, so now it's the other way around. It says find, so I'm going to write this, find an x value. So this is where you have to read the instructions and understand what they're wanting you to do. So you've got the function f of x equals 2x minus 10. Okay, so that is your function f of x, or y equals 2x minus 10. So they want you to find the value of x so that f of x is equal to 6. Okay, so here we go. So find the value of x, and here's your function f of x equals 2x minus 10. So if they give you f of x equals 6, where are you going to plug the 6 in this time? Hopefully you see it just goes right here. You're replacing. So where this f of x is, which is the same as y, you're now putting a 6, and they're asking you to solve for x, so you should know that you are plugging into y and you're trying to solve for x. So now it's just a two-step equation. Add 10, add 10. So now I have 6 plus 10 is 16 equals 2x, divide by 2, and x is 8. So now they gave you the y, which is the same as f of x. They gave you y is 6, and they wanted you to find x. The one before, they gave you x, and you plugged it in and you found out what y is. So let's do another one. If I have another one here. Okay. Let's use the same function here. F of x, let's write it again, equals 2x minus 10. Want you to find the x value, but this time when f of x is equal to, let me see, we had 6, let's say 12. Okay, so I'm just going to go ahead and plug in, make that up and say the f of x is equal to 12. So we are looking for x. All right, so they've given you f of x, so you should know right here, plug it in, 12 equals 2x minus 10. Okay, solve, add 10. 12 plus 10 is 22 equals 2x, divide by 2, and x equals 11. All right, so there, you found x. So be careful whenever you're doing homework. Do they want you to find x, or do they want you to find y? Did they give you x and you'll find y, or did they give you y and they want you to find x? Read the instructions. They're always going to be clear what they want you to do. Okay? All right, we're going to solve a word problem here. I'm going to read it to you, then we're going to make up our own table. Here we go. Let's put it down here. Okay, because we're going to do it ourselves. Okay, so domain and range. I want to read this because it's really important. Hopefully you remember that domain has to do with the x values. Range has to do with the y values. Okay, so the range is the same as y or f of x. They all mean the same. And you can write, they can write as an ordered pair. Instead of saying x and y, here they're saying x comma f of x. So remember, anytime you see f of x or h of x or g of x, it's the same as y. That should simultaneously click in your brain that they're one and the same thing. One is functional notation, and if you just write it y, it's just regular notation, not functional. Okay, so here we're going to look at this here. It's about wolves. So it says the gray wolf population in central Idaho was monitored over several years for a project aimed at boosting the number of wolves. The number of wolves can be modeled by the function f of x equals 37x plus 7. So they have to tell you what everything means, where x is the number of years since 1995. graph the function and identify its domain and range. Okay. So I'm going to go ahead and I'm going to put that, and we're going to start from scratch and do it together. Okay, so here's the function. I wrote this out. So instead of putting x and y, put x and f of x. All right. So we are going to start at 1995. That's our beginning start. So we're going to call that 0. When we start it at the beginning, we always label that 0. We don't need to do 1995. 1995 is 0. Okay, so if we plug in 0, 37 times 0 plus 7, that means in 1995 the population was 7 wolves. All right, so that's what they're tracking. They're trying to track through the years how much the wolf population grows. So after the first year, so you're going to plug in 37 times 1 is 37. 37 plus 7 is going to give us 44. So you should be able to figure out, because I've showed you in detail what we're doing. Then, so this was 1995. This means a year later it's 1996. And 2 years after that is 1997. So we plug in, just so this one, 37 times 2 plus 7, and remember you're always allowed to use calculators. So 37 times 2 is 70, yeah, 75, 70, it's 81. Okay, there we go. So total of 81. Okay, 36 plus 7 is 81. So that's enough. We've got 3 points, and we can see that the wolves are obviously increasing over the years, and that would make sense. Unless they were being killed off, they're going to increase. So here I've drawn a little graph already. So of course we have to label this wolf population. I'm just putting it up here. We have so much room. Let me put the title. Sorry, it's off a little bit. The wolf population. The second thing I'm going to do is, this is going to be 1, 2, 3, 4, 5 years since 1995. You want to put that down, okay? So when we first started, years since 1995, sorry. There, it's kind of squeezed in there. And then this is going to be the number of wolves. Okay, so we're going to do that, and we're going to go ahead and graph it. So I got different colors so it stands out a little bit. When we first start at 0 here, I forgot to put that, we're at 7. So I'm going to do these at 10s. These are 10s because we need to go up to 81. So you don't want to be doing it by ones. So I'm showing that they're all by 10s, 10, 20, 30, 40. This one's 50. 89, this is 90. Okay, squeeze it in there a little bit. So at 0, when they first put the wolves in there, they only have 7 of them. So right under 10. I just kind of wing it a little bit. Then after the first year, 1996, they grow to 44. So 10, 20, 30, 40, just above. So I would say there's about 44. Then in 1997, the year after that, they jump all the way up to 80, 40, 50. So they're starting to get more. 81, so way up here. So you can see that's pretty steep. They're climbing pretty steep right now. And thick like that, and it's going to continue to go like that. But it starts at 7 right there. Okay, so now the next question is, what's the domain and range? You know, across here, this is the X, this is the year since 1995, and then Y, or f of X, is the range, okay? So where does the domain start? Doesn't it start from 0 and go up? So one way that we can call the domain, I'm going to put it here, is x is greater than or equal to 0. Okay, that's another way to write it, or you can say you could say all positive numbers. There's different ways that you can see it, okay? So it starts at 0 and it goes all the way up because the years keep on going. Now the population, the range, what does a range start at? So this is the range and that's the y values. The range does not start at 0. When we look at our graph up here, you look at the numbers here, the range is f of x. It starts at what? 7, right? So here we're going to start all numbers greater than or equal to 7. Because it includes 7, we put the equal sign. So that's the way, or you can say all positive numbers from 7 up. That's another way that you can do it. So there you go. We worked this out together. You can see that you wrote the function, you found the numbers, you titled your graph. Obviously yours will look nicer than mine with nice graphing paper. You titled it, you said what the x values were, you said what the y values were, and then we went ahead and graphed it, okay? All right, so let me take this off. So real quick, I'm going to show you this graph because it's going to be important now. This is a parent function. Parent function for a graph means the major graph where you compare all graphs to. So a basic function, parent linear function, is f of x equals x, or remember f of x means the same, or you could say y equals x, but since we're doing functional notation, understand these are the same things. So it looks like that. You know that's direct variation, so it's going to go through 0, 0. It's also going to be positive. You can see that it's a positive number before the x. So it's 1. So if I start 0, I go up 1 over 1 up, 1 over 1 up, 1 over 1. Same here. Everything is increasing by 1. So that is what a parent function looks like. That means that we compare, if they could tell you to compare it to the parent function, this is the function you should have. It looks like this. Then you do your new one and you look at it and you compare it, how it looks to that. So that's what we're going to do next. Example 4. We're going to graph functions here. So let me get some graphing paper up here. I'm going to squeeze it here. And it says compare the graphs to this one. So everything's being compared to the original function. That's one. But the new graph that they give us is g of x. See how they call this g of x? X plus 3. Okay? So we're going to draw both graphs and then we're going to look at them. Alright? So we know the original one, we just looked at it, goes through 0, 0, and it goes up 1 every single time. So real quick, I can do a few here. 1 here, 1, 1. So the original graph, and I'm going to use a ruler so it looks nice and neat, looks like this. That's the parent function, okay? So they want me to compare the new function, g of x equals x plus 3. So we can see the first one's direct variation, the second one's not because it's got a plus 3. So let's see how it changes. So now I'm going to go ahead and pick some of the same numbers. So if I put a 0 in here, if I start at 0, the same with this one, I have to start at 0, 3. So 0, 3, it does not start at the same spot. This is a new one, okay? Then if I pick 1, I plug in a 1 for x, 1 plus 3 is 4. So at 1, I don't get 1, 1, I get 1, 4. And then I'll do one more, so say we do 2. So now at 2, 2 plus 3, I get 5. So go over to x of 2 and then 1, 2, 3, 4, 5. Okay? So here is the new line. So what do you notice about these two lines? Okay, even though they're not both direct variation, do you notice that the slope is the same? Since the slope is the same, what will the two lines be? Hopefully you're saying parallel lines. You can see that. they're both parallel lines. So if you have the same slope, you have parallel lines. The only thing that's changed is not the slope, but the y-intercept. The original one, the y-intercept is at 0, but the new one here, the y-intercept starts at 3. So that's how that function changes from the original. So now we're going to go ahead and we're going to look at changes from two direct variations. So remember, your original is f of x equals x. Now here the new one is going to be an h of x, the function, but it's got 2x. Alright, so here it fits nicely. So that's my original and that's my new one. Even before we start, they're both direct variation, right? Okay? But are the slopes the same? The slope of the first one is a 1, the slope of this one's 2, so they do not have the same slopes. So let's graph the first one. We know what it looks like. Goes through 0, 0. Every single one is up 1 over 1. So I'll do a couple here, couple here. So we know it looks like this. After a while, you know exactly what the parent function looks like. You don't have to think about it. You know where it starts and just up 1 over 1. Okay? But now we're going to see what 2 times x is going to do. So do you think you have any idea? How do you think it's going to change the graph? Okay, so let's put 3 points. Do you think it's going to make it steeper or not as steep? If I have something and I double it, what do you think is going to happen to the graph? So let's go ahead and use 0. So this one starts at 0, 0. They both start at 0, 0. Then I'm going to go ahead and put a 2 in for x. So if I plug in a 2x, 2 times 2 is 4. Then I'm going to go ahead and plug in a 4 so we can space it out a bit. 2 times 4 is 8. Okay? So those are 3 points. They start at 0, 0 because it's direct variation. But now at 2, 1, 2, 3, I go up to 4. And then at 4, I'm going to go over to 8. So 1, 2, 3, 4, and 8 is all the way here. So what do you notice about the line? The new line is steeper, right? It's twice the other one. You can see it's a lot steeper. So if I put 3 times, you would get even steeper. All right? So they both go through 0, 0. They both have the same y-intercept, but the second one is steeper than the original one. Okay? So real quick here, let's look through the difference here. We're going to compare. I'm going to put this up a bit and see if we can get them all on at the same time. Sometimes I have to lift this up a bit. We're going to compare different graphs real quick. Okay? So here from the original, if you add a plus b, which we did, you can see that it changes the y-intercept. Okay? If it's positive, greater, it's going to make it more steeper. And if it's negative, it's going to put it down. And it can make it more steep or less steep, it depends. So always draw the original, then go ahead and compare it to the parent function. Alright, last one we're going to compare real quick. I'm going to use this here. Okay, we're going to compare a word problem. Let me go ahead and zoom in. So we're going to graph a real world function. So I'm going to use their graph here to save time. Let me make sure I've got all the important information in. There we go. Okay, so let's read it, and then let's look and see if we can answer what they're saying. So pretend that you had to do this graph. So a cable company charges new customers $40 for installation and $60 per month for its service. So I want you to look at this and realize that whenever a word problem says per, that's the same as multiplication. That's going to be the slope. So $60 per month, that's the rate of change. That's the same thing you pay every month. So hopefully you're connecting that to the slope or the rate of change, okay? So the cost to the customer is given by the function f of x equals 60x plus 40. See how 60 times x? 60 is the rate of change, or the slope. That's what the same thing every month. Plus 40 is the installation charge. That's the extra. Where x is the number of months of service. To attract new customers, the cable company reduces the installation fee to $5. So instead of people paying 40 now, they've went ahead and reduced it down to 5, so more people will sign up for the service. So the new function of the cost, see, they call it g of x. That's why they have different letters, because it's not the same function. You're comparing two functions, so you want to have different letter next to it. So g of x is a new function. You still pay $60 a month, so 60 times x, but the installation fee isn't 40 anymore, it's 5. So the new function's plus 5. So graph both functions. How is the graph of g related to the graph of x? So how is this second one related to the first one? So even before we graph, what is the same? If I'm looking here and here, aren't the slopes the same? Okay, so if the slope's the same, what kind of line should you be expecting? And hopefully you're telling me parallel lines. So you should know that they're parallel lines. But one starts at 40 and one starts at 5. So the 5 here is going to be the y-intercept, and the 40 here is going to be the y-intercept. So let's look. So here is the 60x plus 40. I'm going to go ahead and zoom in here. Actually, let me autofocus it and make it, yeah. So you can see here that this was the original. Okay, starting at 40 right here, they've done it by 50, 100, 150, 200. Always look at the increments of a graph and make sure. And then along here, this is months of service, 1 month, 2 months, 3, 4. So as long the x and y do not have to be the same increments, but whatever you start with, you have to keep. So this is all by ones, this is all by 50s. So you can see that it starts up higher and then continues like this. Then they reduce the cost, so the new function starts lower here at 5, but it's still, you're paying the $60 each month. So they have parallel lines, but obviously it's cheaper when the deal is for $5 instead of 40. So that's the difference between the two. So you're looking at shifts. From the original down, you did what we call a vertical translation. So it went down. So whether it goes up or down, they call that vertical translation, because this is the original right here, and the new one went down, so call that a vertical shift. So up and down is vertical, side to side is horizontal. So it did a vertical translation. Okay guys, so we're at the end of chapter 4, so we'll be looking forward to having a test over this. Okay guys.